Hello, my name is Lisa Red Miles and welcome. We are going to be learning about functions today. This is meant to be an introduction to functions, although the students have already been told about the characteristics of different function families such as linear, quadratic, exponential, absolute value. They have been shown the different shapes that these make when graphed. We've talked about the symbolic view of the function, which is the equation. What are some characteristics of a linear equation, for instance, or a quadratic equation, etc. And just the nature of how they grow or decrease. So now we're going to do what's going to start off as a activity that is led by the teacher, me, and then I will go through the group kind of discovery part of it where they have to take their notes and answer some questions. And this will also, in addition to just kind of exploring functions, there's two other things I want to get out of this just as a personal thing as a teacher. I like my students to work as a mathematician or a statistician to really see what it's like to develop ideas with the material, and this brings about critical thinking, you grabbing things from your toolbox of math and taking them and helping you to develop ideas about the nature of a situation, which then later can help make predictions. But for right now, this is just an introductory activity, so we don't really go into the prediction. They have not really worked with developing equations or anything like that. So we're working on that, and also we're working on just the idea of being a good student. When you answer questions or when you're asked something, you have to sometimes go back and search your notes and try to see where does this fit into my notes. So then after they explore that within a group, with me circulating and helping them to answer the questions and keying them in to what study habits and what good studious habits would help them to answer the questions. Then they have an independent activity then that would hopefully reinforce those ideas. So let's get started. We are going to do the following goals. Besides the personal goals I have for any learner of critical thinking and exploratory thinking and grabbing your tools and being a good student, we have the math goals, which are to graph exponential and linear functions on a rectangular coordinate system, compare exponential and linear functions expressed graphically, graph data on a Cartesian coordinate plane, identifying and using an appropriate scale, labeling axes appropriately, and including units. Identify key features of a graph, of graphs of linear and exponential functions within the context of or given mathematical definitions, and determine if an equation is linear, quadratic, or exponential given a graph, and then generate a table of values from an experiment or activity. These different goals were goals in the class where I do this activity. Okay, so let's begin by the teacher-led part of this activity. Jack and Jill are siblings and each want to start their own worm farm as a 4-H project. The club leader helps them each build a temperature-controlled environment which will keep the worms at correct temperature for optimum reproduction. Jack purchases 2 mealworms to begin his business. He researches to find that on average his mealworm population will triple each month. So before we begin to fill in this chart, I like to read Jill's scenario, which is Jill purchases 2 earthworms to begin her business. She researches to find that on average her earthworm population will increase by 40 each month. So we have two different situations here. We have one that is tripling each month and one that is increasing by 40 each month. So I pause here and will say, think about this without doing any mental calculations. Which person's worms will increase at a faster rate? The mealworms or the earthworms? Which one by 6 months will have the most worms? And I have them usually respond if they're in class. I actually kind of do a little bit of a tally. And if it's on an internet, I would have them respond to me personally, and then I would kind of do a tally. So the reason is because most students are going to say that Jill's are going to increase, and by 6 months are going to actually have the most mealworms, because it says that hers will increase by 40 each month, and Jack's tripling doesn't sound as big of a deal. But together we fill them in and we find out the opposite is true. So initially both of them have 2, and then Jack's are tripling, so he has 6 the next month, and then in month 2 he would have 3 times that, or triple, which is 18, and then in month 3 he would have 3 times that, which is 54, and then month 4 he would have 162, month 5, got to do this one on a calculator, he would have 486, and then month 6 he would have 1,450. So we see that by month 6 Jack ends up with 1,450 earthworms. And then when we do Jill's, we talk about the fact that we are just increasing by 40. That means adding 40. So her chart by month 1 is going to have 42, then add 40, 82, then add 40, 122, then and so on and so forth. And then notice in both charts, in month 4 we have 162 earthworms. And then, and before we get to the 162, notice that the first month Jill looked like she was doing much better than Jack. Second month she's still higher. Then we have 122 versus 54, and then we have the same, and then the tables turn. Jack is doing much better, and then Jack's lead increases significantly. So the next step is to graph this with the students. And for my students, a lot of times they come in, they know how to graph, but they forget. So it makes a really good kind of review of how do we graph, knowing that these are our data pairs, 0 to 142, so we discussed that. And we also, very importantly, want to go over how do we label a graph. So that's another thing that students tend to forget. So here we're supposed to graph both sets of data, and it tells them, so we read this, and each set of data needs to be in a different color so that they can differentiate between the two. And so I like to remind them that a graph is a way to communicate what we have found with the data. And so part of a graph, yes, we want to use different colors for the different data sets so we can distinguish between them, but we also want to title our graph. We want to label our axes, because if we don't do these things, then somebody else looking at the graph will not be able to tell what we're talking about or understand the situation. We also would want to provide a key, which would say, you know, whatever color, red, for instance, was Jack's data, or green was Jill's, or however we set it up. And we want to make sure that our x-axis, our horizontal scale, is increasing by a constant increment, and that our y-axis is also increasing at a constant increment. So we need to look at our data to figure out what that constant is. Now, in both cases, the time is increasing all the way up to 6, from 0 times 0 to times 6. So that's not a big deal to just count by 1 on our horizontal axis. That would be our independent variable, and so we can set that up on our horizontal axis. So again, we want to remember that. But we have to go all the way up to 1400 and something on the vertical axis. So we cannot just count by 1. So if we were to count how many different increments we had here, we have 19 different spaces, or tally marks. So when we do 1454 divided by 19, we get approximately 76.5. So perhaps if we were to count by 80 on the vertical axis, then we could fit all of our data. So we talk briefly about these different characteristics of graphing, and these are things they've learned but need a little bit of a review on. So here's our scale, and if you will note, we have titled our graph, we have counted by an equal increment, we have titled our vertical axis, we have titled and put a unit on our horizontal axis, and on our vertical axis we decided to count by 80, and in fact we have, even though it looks like we're counting by 160, sometimes in an effort to make things look neater, we skip every other number. Sometimes we skip 5 numbers or 10 numbers, whatever we want to do, but we have to remember that we actually have to realize we're counting by 80, not by 160, and so on. So when we look at our data, it's going to be hard to graph these because the first tally mark here on our vertical axis is 80. But if you look at Jack's data, the first 3 months are below that. The first 3 months he has data that's just going to be way down here on the graph, below that first mark. So we can only estimate that. And then Jill, it's just the first month. Once you get to month 2, you're above 80, but you can see that we're really going to have a little bit of trouble in that first one. So we do some of these together. So for Jack and Jill both, their first mark was 0, 2. So that's going to be estimated way close to the origin of the graph. And just to show you, let's do Jack's first. So then he had 1, 6, and let's just go all the way up to 4, 162, so that's a little bit higher. 4, 162 is about right here. And all the data before this 4th month was below this 80. So I am just going to have to kind of fit it in there the best I can. Just rising a little. And then finally when I get to 4, I can see where I can put that. And then 5 would be all the way up to 486. And then 6 would be all the way up 1,454. Okay, now for Jill's we'll use red, and we know that at the 0, 2 and at the 4, 162 they both have equal, so I'll put my dots there to begin with. There's the 4, 162. And then for Jill's, at the first month we had 42, which is about halfway between 0 and this 80, so I'll put it right there. And then we had for the second month 82, which is above this 80 slightly. And then a third month was at 122. And then the 5th month was at 202, so the 5th month I'm coming up. This right here would be 240, so it's going to be under it. and then the 6th month is at 242, so slightly above it. Okay, and then we can look at these for Jill's and see that this looks like it's making a straight line, so that's a lot easier to graph. Okay, now so you can compare these two trends in the data. Jill's is making a straight line, and Jack's, it appears to be making a straight line for this beginning section here, but then it begins to curve and curve more and more rapidly. In addition to that, here in the beginning you can see just small gaps, a small difference in between what they have each month, and then it becomes the same. But on the other side of the same, this gap grows very, very rapidly. From here, the 5th month, there was a gap. Sure, it was, large, but not super large. But in the 6th month, it just really is a large gap. And that gap's going to increase more and more rapidly as the months go by. So we have a title and we've labeled our axes. We've appropriately counted by the same scale, and we have a key for our graph. So now this graph is a great communication device which anybody should be able to come up and kind of see what's going on. But with you guys, what I want to do is discuss the shape and a little bit about what's going on in this graph. So look back on your notes and see if you can figure out what function family Jill's data appears to be a part of. And so at this point, some people should say linear. Now let's go back and look at Jack's. First of all, let's describe this from the 0 times 0 to 3. If we were to ignore everything else, what does Jack's progression kind of look like? And usually people say that it's making a line. So it kind of looks linear, and then it starts to curve more and more rapidly. It's increasing, which are part of the characteristics the students were given for exponential. So they look back and they see that this is an exponential growth. Then I do kind of give a disclaimer that mostly the biological system is such that animals reproduce and insects in a more of an exponential fashion. But I changed it to represent this problem. Okay, now we're going to, the students are going to get into groups, and they're going to answer some questions together as a group. Now the first few questions we've kind of already discussed, so they shouldn't be too hard, but then they do get harder. So we'll go over them, and I'll see if I can maybe remember to point out some things that students discuss or what they usually have problems with. So first of all, the question or the idea is for them to describe the shape created by each data set when graphed. What function family or type does the set of data belong to? And then to use complete and legible sentences. So that we've already discussed, so that's usually a no-brainer. And then depending on the class, if it's an advanced class or not, I'd add these questions. What key features were in the wording of Jill's earthworm farm that could have keyed you into knowing that it would end up linear? And we already have identified it as linear, so I do put that in there. And then the other one was, what about Jack's? So the idea here is for them to understand that things like increasing by a constant amount, that is an idea of slope. Increasing or decreasing by a constant rate. And in Jill's context, it said that it was increasing by 40 worms per month. And so the other idea is that a slope has two units connected to it. worms per month, 2 ideas. And then with Jack's, his is tripling. So exponential, do things like triple or double or half. And we've already discussed that. I gave that as the verbal representation of a function, things that they want to look for in the wording of a real life problem. And then we go on to telling when are they equal, and that would be in month 0 and in month 4. When do they have the same amount of earthworms? So in month 0 they had 2 earthworms, and in month 4 they had, I believe, 162. Then during what time intervals did Jill have more? And they are to do this in set builder notation, which again is something they've learned. So the set of all x's such that 0 is less than x, which is less than 4. Now we have done set builder notation, but at this point we haven't explained that this is the domain of the equation. And then for Jack we would have the set of all x's such that 4 is less than x, which is less than. Now here we have a little discussion. Some groups want to put 6, which is fine, and I accept it because that's the data we explored. But I like to talk to them about, well, what about month 7? Who's going to have more? 8, 9, and so on. So then some groups want to put the idea of infinity. That from here to infinity, Jack is going to have more than Jill. So that idea we explore a little from a biological or natural sense, in that there will actually come a time when the holding cell for the worms, or the place where the worms are habitating, is not going to support growth, continued growth. So there will be an endpoint. So we just kind of talk about that a little bit as they're in groups and explore that idea. But I accept 6 or infinity, or if they have justification, any other month. Then, as long as it's higher than 6. And then 9 requires that they go back to the graph, kind of extend the equations, and with a guess and check, try and figure out, well, when will Jack triple Jill? And that kind of just lets them lead into the idea of using the graph as a tool to find this out. And then in 10 months, how many earthworms will each of them have? So again, they're going to estimate by extending the graph, and that's going to be really hard to do as far as Jack's, because his will go off the chart. But just to kind of have that idea of using the scale they've already established to continue it. And then 11 is a guess and check. See if they can develop the equations, or just at this point, just Jill's equation, because they have been told that Jill's equation is y equals mx plus b. So I want them to play around with this idea and see. Some of them may even have a little bit more experience with this equation than others, so they'll get it right away. And some of them may not really know how to do it. So we talk about, if they're struggling, I talk about what does B represent. Go back to your notes and see. B was your initial amount, your starting point. So then they usually get to, yeah, okay, so they both started with 2 worms. And then M was your rate of change, or your slope. So then they very often get to the idea that the rate of change would have been the 40. So it's y equals 40x plus b. And then finally, I have a take-home activity for them. They do independently. And we do usually start, I draw them all back together, and we do the beginning of this so they understand the setup. It's a little hard to understand. But Jill just decides she's discouraged with her earthworm farm, and so she decides to do sheep. And they have 144 meters of fencing, so that's their perimeter. And so if they want their length to be 2 meters, and they have 144 meters of fencing, then what would the width be? So they use this formula to figure that out. And then I think that would be 70 meters. And then they get to choose their own numbers between 2 and 12. And then their own numbers down here between 12 and 36. So I've put a few numbers in here just to make sure I keep them on track, and because I want them to see a definite shape here. And then down here, they transfer this idea, now finding the area. So if their length was 2, that meant their width was 70, sorry. So now they have to find the area. So the area would be these two multiplied together, so that would be 140. So then they transfer that data down here using the same length for each spot, but a different area. And of course what they get is a parabola. And so then they have to identify it as a parabola, and the coordinates of the vertex are within these numbers, so they identify the vertex and the fact, and then just anything, other characteristics about the graph. So that concludes this kind of introduction, a little bit of discovery, a little bit of how do I use my notes to answer bigger problems, how do I go back and search for ideas, and it's a good introduction to functions as well. This concludes our introductory discussion on functions. I hope you enjoyed it, and I'm really looking forward to possibly working with you. So I hope to hear you soon. Thank you.